Many of the common methods for the preparation of alcohols have been discussed in previous chapter or will be considered later. One of the methods to prepare an alcohol is through fermentation. So fermentation is a biological process of enzymatic degradation of sugars by microorganisms. But this method only to prepare an ethanol. You can't make any other alcohol this way. Another method to prepare an alcohol is through the hydration of alkenes. You had learned this in chapter 5.2. In this reaction, alkenes will react with an acidified water to form an alcohol. Since the type of reaction is an electrophilic addition reaction, an electrophile will be added to the carbon-carbon double bond, which is our nucleophile. To determine the product form, we have to follow the Markovnikov rule, where it states that in addition reaction, electrophile, in this case which is our H+, will be added to the carbon that contains highest number of hydrogen, and then our OH group will enter the carbon next to it. Alcohol also can be prepared from the hydrolysis of haloalkane. We had learned this in chapter 7.2, where an haloalkane will undergo hydrolysis by using an hydroxide ion. Okay, so hydroxide ion is a strong nucleophile that comes from aqueous solution of sodium hydroxide or potassium hydroxide, or from a weak nucleophile, which is water. The type of reaction is a nucleophilic substitution reaction where the halogen group will be substituted with the hydroxyl group. The addition of Grignard reagent to carbonic compounds may form a different types of alcohols. We had seen this reaction in chapter 7.2. Grignard reagent is prepared by the reaction of alkyl halide with magnesium in dry ether. When the Grignard reagent is treated with a methanol followed by hydrolysis, it will form a primary alcohol. The reaction of Grignard reagent with aldehyde except for methanol followed by hydrolysis will produce a secondary alcohol, while when Grignard reagent is treated with a ketones followed by hydrolysis, it will form a tertiary alcohol. Since the addition of the Grignard reagent to the carbonic compounds is a stepwise reaction, the first step involves the nucleophilic site of the carbon atom that bind to the organometallic, which is our magnesium halide here. Right, so the bonding will attack the backside of the carbon double bond O. The carbon double bond O here is an electrophilic site, so it will act as an electrophile and makes the electrons from the carbon double bond O, right? So the double bond here will become a single bond where the two electrons in the pi bonding here will goes to the oxygen, and then it will form an intermediate metal alkoxide complex. In the next step, the alkoxide intermediate is then converted to an alcohol through hydrolysis. Sometimes there are 2 or 3 possibilities to prepare an alcohol via Grignard reagent. For example, here if we have 2 butanol, so the OH group is attached to this carbon. So from this carbon, we can see that we have 2 different alkyl group attached to it. So when we have 2 different alkyl group attached to it, that means we have 2 possibility in order to form the 2 butanol via Grignard reagent. The first possibility is when we have CH3 MgX as our Grignard reagent, and the other possibility is we have CH3 CH2 MgX as our Grignard reagent. If we use CH3 MgX as our Grignard reagent, the other things here will become our carbonyl compound. Since 2-butanol is a secondary alcohol, so the 2-butanol will produce when the Grignard reagent reacts with an aldehyde except methanol. So in this case, our aldehyde will be, right, so we have C double bond OH, right, so let's draw it, C, Okay, the single bond OH, we change it into double bond O. Okay, and then erase the hydrogen here. So because we need to have our carbonyl compound, and then next to it we have CH2CH3. So the reaction of Grignard reagent with this aldehyde followed by hydrolysis will produce a secondary alcohol, which is 2-butanol. So the second possibility is if we have CH3CH2MgX as our Grignard reagent, so the other thing here will become our aldehyde. Okay, so in this case, our aldehyde should be CH3, C, single bond OH, change it into double bond O, and then we have hydrogen here. Okay, so we have our aldehyde. Okay, so there are two possibilities to form a 2-butanol via Grignard reagent. Okay, the first one is if we have CH3MgX as our Grignard reagent, so this is our aldehyde. If we use CH3CH2MgX as our Grignard reagent, so this will become our aldehyde. Last but not least, alcohol also can be prepared by reduction. The reducing agent that can be used is sodium boron hydride in methanol, lithium aluminum hydride followed by hydrolysis, and catalytic hydrogenation. Reduction of aldehyde will produce a primary alcohol, while ketone will produce a secondary alcohol. When carboxylic acid undergoes reduction, it will produce a primary alcohol.